Right, you each should have in front of you fractions review. What we're going to do today is talk about, there's a lot going on that paper. There's adding fractions, subtracting fractions. Go down to the part where it says multiplying fractions. So go down to number 17. Go down to number 17 and just bear with me for a few minutes here while we talk about how do you multiply fractions. If you remember correctly, when you multiply fractions, all you have to do is multiply straight across. In other words, numerator times numerator, denominator times denominator. And then you simplify it at the end. So you literally, in this case, multiply 2 times 4. You multiply 2 times 4 on the top, and on the bottom you multiply 3 times 5. What is 2 times 4? It is 8. What is 3 times 5? It is 15. Now this is your answer. 8 over 15 is your answer if 8 over 15 does not reduce. Does 8 over 15 reduce? And you should know whether or not it does or doesn't, but if you don't know, make sure that you check on your calculator. Sometimes you'll think that it doesn't, but then it actually does. All right, the second one. 5 times 3. All right, and then in the denominator you have 6 times 4. What is 5 times 3? 15. The bottom 6 times 4 is 24. What is 15 over 24? I know that does reduce. Yes?
5/8.
It reduces to 5/8. So you would end up with 5/8. All right, number 19. 7 over 8 times 1 over 2. You multiply 7 times 1 on the top. On the bottom you have 8 times 2. So you end up with 7 over 16, and I believe that 7 over 16 does not reduce, so you would leave it as 7/16. I am not going to go through every single one of these with you, but what I would like you guys to do is just quickly finish up 17 through 24. Stop at 24. Do not go any further. We will talk about 25 to the end of the paper in a little bit, but for right now, just quickly finish up 17. Even the ones at the top, you guys, the adding and subtracting, if you know how to do those, don't do them yet, because I might show you some tricks that will help you when we are applying this to rational expressions. So go ahead, finish that up, and then we're going to talk about rational expressions here in just a minute. Now the paper that I'm giving you right now is all about multiplying rational expressions, because of course we're not just going to multiply fractions in here, we have to make it a little bit harder than that. So I am handing you right now a paper called Multiplying Rational Expressions. On the back side of it, it says Dividing Rational Expressions. We are just going to worry about multiplying right now.
It's GH, and you're like,
Yep.
Okay, so in front of you, you have multiplying rational expressions. We are going to apply the same techniques that we just used on that fractions paper. So problem number 1, when you are multiplying these two fractions with polynomials in it, you can do one of two things. You can go ahead and just multiply numerator times numerator, denominator times denominator, rewrite the problem. But my suggestion would be to try to simplify it first. If there is something that is alike on the top and the bottom, get rid of them. So in this case, is there anything in the numerator and in the denominator that are exactly the same?
What about them C's?
What about them C's?
Want to add those?
oh, the
Well,
twos.
we have a 2c plus 2 in the numerator. We have a 2c plus 2 in the denominator.
The twos
If
are
something is alike in the numerator and the denominator, what can you do to them?
cross them
Cancel them out. So you cancel them out.
But they're-
So
they're-
all
they're-
that's left over now is c plus 6 on the top, and then in the denominator we have c squared plus 14c plus 48. So think factoring. Try to factor things because c squared plus 14c plus 48 certainly doesn't look anything like a c plus 6, but there might be a c plus 6 that's hidden in here. So what you need to do is look for two numbers that will multiply to give you 48, and when you add them together, they get you 14. 6 times 8, yeah, 6 times 8 is 48. You add together 6 and 8, you get 14. So the bottom of this factors to c plus 6 times c plus 8. I'm going to cross off the original trinomial there, so I'm not looking at that anymore. I don't want to confuse myself. Is there anything that's alike to the numerator and denominator now? There should be a c plus 6 alike to the numerator and denominator. What's left over now?
C plus 8.
There's a c plus 8. And where is the c plus 8? It's on the bottom. So I'm going to put c plus 8 on the bottom. What goes on the top?
Yeah, one.
A 1. Don't forget about the 1. There's always going to be a 1 there left over on the top.
But what about, why did you know how you said 2c plus 2? Why did you cross them out on if they're not in the same fraction?
Well, remember when you, okay, his question was this: why is it that I can cross off the c plus 2 on the top and the c plus 2 on the bottom when they're not in the same fraction? Remember when we were just talking about those fractions, like without polynomials in it? Remember how you took the numerator times the numerator, and then you took the denominator times the denominator. So really, they all become one expression. What this really becomes is 2c plus 2 times c plus 6. You see where I'm going with this? And then on the bottom, we end up with a c plus 6 and a c plus 8 times a 2c plus 2. And the 2c plus 2's cancel out, because you understand now, it's really all one thing.
Oh.
Okay, one, and then the c plus 6's cancel out, you're left with the c plus 8 on the bottom. Alright, number 6, 5/10 times 7 over 11h. If you can reduce things, reduce them to begin with. 5 over 10, what does that reduce to? 1 over 2. Do that up front if you can. 1 over 2. And now just multiply the leftovers. We have a 1 on top times a 7 on the top. What does that give you?
Oh, 7.
7 on the top, and then we have 2 times 11h is 22, is 22h.
That's pi. One of-
Alright, number 2. Z squared plus 19z plus 90 over z plus 10 times z plus 9 over 5. Is there anything alike right now? Can you cancel anything out right now?
No,
Cannot cancel anything out right now. Nothing is alike. So what I'm going to do is factor. I'm going to factor this z squared plus 19z plus 90. What two numbers will multiply to give you a 90, and when you add them together you get 19? 10 and 9. So that means this factors to z plus 10 and z plus 9. Now can you cancel anything out?
yes.
What can you cancel out?
z plus 10.
The z plus 10s cancel out. What about the z plus 9s?
And z plus 9 squared.
Oh.
Yeah, you cannot cancel out the z plus 9s because they are both in the numerator. You have to have one in the numerator, one in the denominator in order to cancel them out. So you are going to be left with z plus 9 twice. So it's squared. What's left on the bottom? It's going to be a 5 left over on the bottom. Number 7. What can I cancel out?
3p plus
Yeah,
4.
this 3 times p plus 4, 3 times p plus 4. They completely cancel out. What are you left with?
8p over 4.
You are left with 8p over 4, but 8 over 4 is reducible. 8 over 4 reduces to what? 2. 2 over 1, or just 2. So 8p over 4 is the same thing as 2p.
I get it.
Now we're going to try to be mature. mature. Try to be mature, okay? Number 3. Anything alike to the numerator and denominator. Anything alike to the numerator and denominator.
Y minus 9.
Y minus 9. So we have a y minus 9 on the top with the y minus 9 on the bottom. What else? Y minus 3, y minus 3. What's left over?
6y.
Okay, so we have a 6y on the top. And then in the denominator we have a y plus 2 and y plus 12. Ooh. Now, can I do this? Can I cancel out this y that's next to the 6 with this y right here?
Yes.
Why would you do that?
No.
Could you, my question is, could I do that?
No.
This is not a y. This is a y plus 2. We may only cancel out a y plus 2, anything about it, with another y plus 2. Okay? This is being multiplied. These two things are being added on the bottom. All right, number 8. Nothing is alike right now, but I certainly can do some factoring and canceling. So look at this. What two numbers multiply to give you 66? Add together to give you 17.
11 and
D plus 11 and D
6.
plus 6. Can I cancel anything out?
Yeah.
Yes, and you know what, you guys, usually there's going to be something that cancels out. Not all the time, but usually. What's left over? D plus 11 squared, because it's twice. We have 2 of them. So we have D plus 11 squared, all divided by 4.
Wait, no, D plus 11. Where? Oh, oops. Yeah, I took that out.
You're done.
Alright, 4 more. Number 4. We have B plus 8 times B plus 9 over B plus 8 times 7 over B plus 3 times B plus 8.
Whoa.
Is anything alike? Can I cancel anything out?
Plus
Yes.
8.
Do it. Cancel them out. We have a B plus 8 here. We have a B plus 8 here. What about that B plus 8?
Don't talk
Yeah,
to me.
can't cancel it out. 1 for 1. You can cancel out 1 on the numerator with 1 on the denominator. Not 1 and 2. 1 for 1, okay? By the way, I didn't have to cancel out that B plus 8. I could have canceled out that one instead. Doesn't matter. All right, what's left over?
B plus 3 and B plus 8.
Okay, on the bottom, we have a B plus 8 and B plus 3. In the numerator, we have a 7 and B plus 9. That's it. Nothing else is alike. Can't cancel out anything else. Number 9, cancel anything out that you can to begin with. What can I cancel out?
Q. What? No. We have to factor.
Yeah.
Oh, so basically just multiplying rational expressions.
Yes.
What?
What?
Syllables.
Is there anything that I can cancel out right now?
9?
Come on, guys. What can I cancel out? What's alike to the top and the bottom right now?
Q squared.
No.
Q.
Because it's not Q squared, it's 77Q squared minus 77Q. That screws it up.
Why you can just
Q.
show?
Look at this. We have a 5 here and a 5 here. Q. Huh? Oh, we have a Q.
Just
Yes, we have a Q.
Oscar Massey?
Alyssa, can you grab that for me, please?
Sorry.
All right, yeah.
Use minus
We should have
77.
sleep time in class.
Minus 7.
What? Sleeping time.
Never mind. I'm not like 2% down.
You're at like 2%. Okay.
Yeah, 5%.
Who does? Jimena? Okay. All right, Tom, let's factor it. What does a 77Q squared minus 77Q have in common? Donovan, what do they have in common?
37Q.
They have a 77Q, yes. I'm going to take a 77Q out.
No, right.
All right, if I divide a 77Q out of 77Q squared, what's left over?
Q.
Q. We have a minus sign, so we put a minus sign. I divide this by 77Q. What are you left with?
1.
1. Very nice. So we have 77Q times Q minus 1. What about the denominator? What does 110q squared minus 110q have in common?
Serious.
U minus what?
We have
That's
a
so popular.
110q in common. Which again is going to leave us with q minus 1.
Negative.
Q minus 1's cancel out. We have 1 in the numerator that cancels out with one of them in the denominator.
What happened to the other Q? Divide.
The what?
Yeah, there's a real Q out there.
Thank you.
Well, there's this Q right here that cancels out with that Q right there.
Q right next to
And all that's left over, yep, we still have this Q.
Oh,
So
I
we have a
forgot about that.
77Q over 110. Now, do not assume that that fraction is not, at first glance, you probably think it's not factorable.
Why does 110? Why does
They are really playing.
why does
Wow.
110 with the Q?
Watch it be,
If
watch it
77
be
still has
thick.
a Q.
Very hard.
It's okay.
I knew it. I done knew it.
What?
I done called that.
do it.
Did you say sorry for calling somebody's names?
Okay, you guys, can we please stop? I know that's distracting, but come on. You're mature enough to be able to focus even though the phone is ringing, okay? All that we have left is a 77 and then that Q that was next to the 5s that we canceled out. So we have a 77Q left on top. We have a 110 on the bottom. Yes. Yes. 77 divided by 110, that reduces.
So 7 11.
77 over 110 is equal to
7 11.
7Q over 10.
Wow. Oh, wow.
Well, both 77 and 110 are divisible by 11. So you divide them each by 11, you end up with a 7 on the top. Just check on your calculator. 77 divided by 110. Remember the trick? Math, enter, enter. Changed it back to a fraction for you, a reduced fraction. 7 over 10. Oh, 79, that was a Q. That was a really bad Q. All right, number 5. I can cancel out the 6 times S minus 11. All I have left is the 7S in the numerator.
That was easy.
And then the denominator we have an 11. That's it. That was an easy one. You're right.
7x.
Well, this
Alright.
number's 5.
7s over 11. Number 10. Nothing cancels out initially, but I can factor this 2k minus 22. What does a 2k minus 22 have in common?
2 and then K minus 22.
Okay, so I factor out a 2.
Or no, minus 11.
It leaves me with k minus 11. The k minus 11s cancel out. All that's left is 10 times 2, which is 20. And then on the bottom, I have k plus 9.
Do we have to put in parentheses? Parentheses?
What in parentheses?
K plus 9.
No, I didn't put it in parentheses.
I know, but do we ever have to?